Hi, in this video, I'd like to show you or give you a demonstration of how to use the decision-making tree package in the Python provided by the sklearn library to use, how to use the package to build a classification tree. And here we use the data of the National Household Travel Survey data. It's just a demonstration. And so the basic principle of the decision-making tree is to kind of optimize or maximize the amount of information for either each question that we're asking for each layer, or the overall compound or joint distribution for the possible and all the possible answers. We're trying to make this distribution as flat as possible. So we can start with importing some very basic libraries and modules such as Panda and NumPy and the operating system OS, as well as of course the matplotlib library. But here we probably won't use that, but just in case later I want to do a little bit additional analysis. Besides that, we need to specifically import some modules from the sklearn, the cross-validation module. It's very important. We need to get the training data set as well as the test set. Besides that, we need to specifically import a tree module in which we specifically need the decision tree classifier, which is a Python sklearn object, and we need the sklearn matrix in order to do some post analysis to figure out the accuracy of our prediction. So before we do that, because I didn't change my dataset's location, so I need to change my directory through the os.change directory to change my directory. Let me run these two lines first, and then here I create the Panda data array through a reading from the CSV. This is the National Household Travel Survey. There are specific data sets for only the household, but the attributes of each household they're making, and then the weight of that household. And once we import that, we can clean that by dropping all the NA field, and we can just show some of the information here. Let me run it, and you can see we have all those types of information, and we can further explore all the columns names. And they have a quick book. Let me show you over here, and to have all the explanation about each possible column. Let me show it here, and you can see, for example, I used one of the column as this CDIV MSAR. Let me type CDIV MSAR. It's here, and it's a grouping of household by combination of census division, and we specifically use the 91, which is the Pacific, the survey region, with more than 1 million or more, with the high-speed rail, not high-speed, the heavy rail. Here, because we were interested in Los Angeles and San Francisco area. And we specifically define the predictor. Here we just extract some of the important factors, I think, because these are just a demonstration. I import the household and the household race type, whether the housing is rented or owned, and the housing type, which is apartment, condo, etc., and the population density around that the tract level the area. And we using the train test split to by 30% to versus 70% to split the data into training data and testing data, and we can check the shape of all those data sets, and that's what we want. And we can start building this two most important commands in order to create a classifier that have all the decision-making process, decision trees structure, as well as data in it with the estimated parameters or estimated the structure. And we can input the test data into the classifier predict method and to get the predictions, and we can use, let me run this really quick, and this, and then we can get the using this prediction comparing with the original one, the real result. We can get a matrix, confusion matrix. We can know that for the diagonal is actually pretty good compared to the off diagonal elements. That means we're actually have some prediction power, and we can set the original target set. We have like 6 categories, and now like probably because the tree that it optimizes the possible prediction, there are, even you check the cookbook, you'll find that actually the 6 the category is actually not a lot. So it's kind of understandable, and it's also understandable to not have that prediction, and we can further actually run that and find the prediction power, which is about almost 50% of the explanation power. And compared to actually we have 7 categories. Okay, so we actually have so originally the power will be about 1/7, so it's about 15% of the. So if I don't have any decision tree model, my explanation power is about 15%, and now because of this model, I improve it to be about almost 50%. So, but of course, we can further improve the model by adjusting the parameters, and we can use the random forest, which I will talk about in the next video. And we can plot this actually, plot the tree, but here I'm gonna just save it into a tree dot with all those features. Okay, let me run it, and then you can see which is somewhere here, okay, in the tree, and we can further do the analysis about this. Is a text-based file for explaining the tree, but we can also visualize it by using this file, by using the string OS, and then we can import the file like this. Okay. Import the pi.plus, and then we set the graph as the pi.plus, and then using the graph from .data, and then we can set the value and then print out the image through the graph dot create PNG as an image. So yeah, so here is the demonstration, and hope I will do the random tree forecast hopefully soon in the future. Thanks.